Hi everyone, we are Team Forte and this is our poster video presentation. My name is Helen Rogers.
I'm Jordan Armstead.
I'm Catherine Chonai.
I'm Nathaniel Zucker.
And our project was to design a custom shoulder and chin rest for Dr. Topolesky's travel violin. This violin is much smaller and differently shaped than a standard violin, so he needed a custom shoulder and chin rest. He also asked for us to design a full-length bow that he could travel with. His current bow is much shorter than a standard violin to be able to fit in a suitcase, so he wants a bow that can collapse down. Here is our functional block diagram where the user places the shoulder and chin rest onto the violin and makes any adjustments to make sure that it's comfortable. Some of the key requirements for our system are that it needs to attach without damage. It shall weigh no more than a quarter pound. It needs to be comfortable and easy to assemble.
Here's our mission scenario diagram, just describing the steps required to assemble the chin and shoulder rest. Shoulder rest affixes from the bottom using a press fit mechanism, and the chin rest just sits on top of that and it aligns with the press fit fasteners, and then it just slides right on into the keyholes using and then it snaps into place with the snap fit mechanism, preventing it from moving axially along the violin. And here's our design evolution, starting out with our initial concept, which uses a hinge design with the shoulder rest on the bottom and chin rest on top. Our second design eliminates that hinge and makes use of a traditional violin clamp, and is also more ergonomic with an offset chin rest. Our final design is very similar to that previous design, however it eliminates the traditional violin clamp and uses a male and female cutout and fitting that holds everything together. And for our finite element analysis, we used a material of ABS plastic and a distributed load of 10 pounds on the chin rest. This resulted in a stress concentration at the bottom corners of the chin rest, maximum of 0.91 megapascals, and a maximum displacement of 0.08 millimeters. Essentially no yielding will occur because ABS plastic has a yield strength of about 50 megapascals.
Okay, so here we have the bow and chin shoulder rest case. The full-length bow has to be collapsible for travel purposes. So the way we're going to do that is to split it into two parts and then use a ferrule from a fishing rod to hold the two parts together. And then the bow hair is going to be stored in the plastic bag.
Since the previous PVC case was only just big enough to carry both the violin and the original bow, we decided to use this bag to contain both the chin shoulder rest components during transport. The straps will attach directly to the violin case, and the bag is colored black as per Dr. T's request.
So for future testing, we need to find the best location for the ferrule so that the weight distribution of the bow is just like that of a normal bow. And then secondly, we need to have Dr. Topolesky test out the chin shoulder rest to make sure it's comfortable, stable, and easy to use, and also that all the components fit well in the traveling case.
We would like to especially acknowledge Dr. Gerganis and Dr. Topolesky for your contributions. Thank you.